All right, so we would like to solve number 5 in chapter 8, which is something about boxing apples. Okay, so I have boxes of apples that this company is going to crate together. So in one of the boxes, they've got 4 Pippin, 4 Mac, and 4 Fuji apples. In a different box, right, in box type 2, right, they've got 6 Pippin, 3 Macs, and 3 Fuji. And box 3 is for people who hate Pippin apples, right?
The soft ones.
They've got,
soft.
which one are the Pippins?
They rattle when you shake them to eat. They're really good. Juicy.
This sounds weird. I wouldn't want to eat that.
The galas or whatever, they're soft, right?
Okay, and then, no, this is what they gave us. And they have 8 Macintosh and 4 Fuji in that box, right? So every box has 12 apples in it, but the kinds are mixed together differently. And then they said, and also the company has access to 2,800 Pippin apples, 2,200 Macintosh apples, and 2,300 Fuji apples. I'm supposed to figure out what's the maximum number of boxes I can create. 27. I think I could probably do better than that just by making box 3s, right? You guys see that?
Or box ends.
Okay. Anyway, so what I need to do is somehow make this into constraints, right? Maybe the first things first would be to identify a thing to optimize. What am I supposed to be optimizing? What are the variables here?
Boxes.
Boxes, right? So how many box 1s are you going to make?
X1.
Yeah, I don't know. I'm going to call that box 1,
Nice.
right? I'm going to call this one box 2. And I'm going to call this one box 3, right? So total, how many boxes am I going to make?
B1 plus B2 plus B3.
Box 1 plus box 2 plus box 3, right? And really by these variables, I mean the number of box 1s I made, the number of box 2s, and the number of box 3s. So equals what?
T and B, total number of boxes.
Yeah, this is like my total. This is the thing I'm trying to optimize. And I remember that the Simplex method uses a Z here, right?
Of course it is.
Okay. Now what? What else do I have?
Make more equations.
I need more constraint equations. So what are my more constraint equations here? So this right now, this is my objective equation, which I located. So I'm pleased with this. Now what else?
Would you have like 4B1 plus 6B2 plus just that, and then equals the 2,800 for the Pippins?
Okay, so I got 4B1s plus 6B2s plus 0B3s is,
Would that be the 2,800 Pippins?
you think it is 2,800?
Because that's what the number, I don't know, that's what I'm asking.
Less or equal to?
Yeah, so this needs to be less than or equal to, right? Because I don't have to use all the Pippin apples. There might be 1 or 2 left over at the end. You guys see that? This is going to tell me how many apples I can eat while I'm boxing, right? There'll be a couple left over. Hopefully I can eat them. And what else? Let's see. What else you got? So that's Pippins, right? So maybe we should keep track of which one came from where. So this was the Pip apple constraint. What other constraints have I got?
So then you have 4B1 plus 3B plus 3B2 plus 8B3.
Okay. Is smaller than or equal to,
2,200.
that's the Macintosh equation, right? Okay. And what do you get for your Fuji constraint?
4B1 plus 3B2 plus 4B3. 4B3.
4B3
Less or equal to 2,300.
is smaller than 2,300. Cool. All right. So what else is there?
They all have to be greater than 0,
Yeah, they all have to be bigger than 0, right? Okay, anything else? Are there any other constraints present in my system?
Bigger than 0 or just not less than 0?
Not less than 0. Because I definitely don't have to make any of box 1, right? Like, if it comes out to be better to only make box 2s and box 3s, I'm okay with that. That's cool with us? Alright, so what do I do now?
Add slack.
make
Okay.
a table and add slack.
Make a table and add slack. I think I add slack before I make a table.
Yeah.
Okay, so how am I going to add slack to this? What are the 3 slack variables going to be?
Y1, Y2,
Keep it
Y3.
Good. Keep it simple. So let's see. I'm just going to go through and throw these in right here. So I'm going to add y1 to this first equation, y2 to the second one, and y3 to the third one. And then I'm going to go through and what?
Make the equations equal to what they are less than or equal to.
Perfect. I'm going to restate all of these as equality after I added slack. Okay. So, what does y1 represent now?
The amount of leftover pippin apples.
Perfect. That's leftover Pippin apples. Y2 is leftover Macintosh, and Y3 is leftover Fuji apples. You guys with me on that? Okay. So now what?
Now you
Oh, what else do I need to do? Forgot one thing.
make Z on the other side and set it to
Okay.
it's positive and it equals 0.
Okay, so I want Z and some stuff and equals 0. How do I arrange that? What am I doing?
Minus B1, minus B2, minus B3.
Perfect. So subtract your variables over, get this thing equal to 0. Keep your Z positive, right? Okay, so now I need to construct my table. Okay. So, how many columns is my table going to need to have?
7, 8.
8. Lots, right? 3 for the B's, 3 for the Y's, 1 for the Z, and
1 for the number.
1 for the numbers. So I think I've got, let's see, maybe the bottom row's easiest? What do you got for your bottom row?
Negative.
Negative 1, negative 1, negative 1, 0, 0, 0. Whatever Z is Z1. Yes.
1,
0.
stick with that. So I've got a B1, B2, B3, Y1, Y2, Y3, Z, and numbers columns. Well, okay. How about your first constraint row? What do you got in that?
4, 6, 0, 1, 0, 0, 0. 2,800.
Perfect. Cool. You guys all with that? All right, second row. What do I got?
4, 3, 8, 0, 1, 0, 0.
2,200. Perfect. Very nice. And the last row I've got 4, 3, 4, 0, 0, 1, 0, 2,300. Good. Okay, so now can I read off what vertex I'm sitting at right now? Okay, so that right now, default, I'm sitting at Y1 is 2,800, Y2 is 2,200, Y3 is 2,300, and Z is 0. That's apples are in a pile and the boxes are all empty. Okay, see that? Okay, so let's start filling some boxes. So how do I start filling some boxes?
Well, normally you look for the biggest payoff, but they're all equal. So what do you do for that one? Can you just pick one then, or do you do the first one?
You guys all see that? Like, the payoff's the same in all three of these, right? So pick one. I don't really care which one it is, right? They all pay off the same amount, so I'm just gonna pick whichever one seems like the best idea.
The first one.
Yeah, and the first one seems like a really good idea. Okay, so I'm gonna look at this first column, which is gonna be, I'm gonna stick some,
You need to find the pivot.
yeah, I'm gonna stick some apples in box one, right? You guys see that?
Pick one, if they're all the same.
Yeah, they're all the same, so it doesn't matter which direction you go, so pick one. So I picked the first one because it was the first one, and for some reason that makes my heart feel better than the other one. And then I need what?
The most constraining constraint.
Yeah, I gotta find the most constraining constraint. So if I look at these, in my first row here, what's my quotient?
700.
Yeah, so I'm doing 2,800, right, divided by 4, getting 700 out of that. That means I could fill 700 boxes of type 1 with Macintosh apples. You guys see that? That's just according to the first constraint, right? That's if I used up all the Macintosh apples. Sorry, if I used up all the Pippin apples. My bad. I'm just reading the wrong row. So if I used up all the Pippin apples, I could make 700 box ones. What happens if I used them all to make, or if I used all the Macintosh apples? Oh,
You can only make 550.
550. Okay, so clearly I can't make 700 because I don't have enough Macintosh apples to do that. And the last one, 2,300 divided by 4,
575.
is more, right? 575. Okay, so I'm finding the lowest number, right? The lowest quotient. That's my most constraining constraint. So here I am. That guy's my most constraining constraint. Okay, so now what?
Pivot operations.
Okay, so now I gotta do pivots for this thing. So I'm gonna leave the, what?
The 4. The middle 4 that represents Macintosh.
Okay, how about this? I'm gonna leave the first constraint and the second, or sorry, first and third constraints alone, and this last row. So I'm just gonna leave my constraints I'm not using and my objective exactly alone. So I got 4601000, and augmented by 2,800. That's my first constraint. Second constraint row is going to be 4340010 2,300.
You mean the third one?
Sorry, I said second and the third. Yes. So that I'm just rewriting. Yeah. And this bottom one's going to be -1, -1, -1, 0,0,0,1, augmented by 0. And now what did I need to do to my pivot row?
Make it 1.
Yeah, I need to make that pivot 1, so I'm going to divide the whole thing by 4. Oh, actually, it probably would have been smarter. Oh, here I am. So I'm going to divide the whole thing by 4. So I got 1 3/4, 2 0 1/4 0 0
550.
550. Okay, now what?
Then
I
you
gotta
make
do-
the other 2 4s 0.
Okay, I gotta do two things. I gotta make these 0, and I gotta make that 0.
Great.
Okay,
Why
So-
did you divide that by 4?
to make this pivot 1.
Oh, because you didn't count
I probably should have zeroed these out first and then made the pivot 1. Because now I'm going to have to frickin' write down this thing times -4 up here and up here. Okay, but luckily I didn't erase it, so I don't have to undo that work. I'm just going to go grab my pivot row from up here and slap some minus signs on it. So that's -4, -3, -8, 0, -1, 0, 0, -2,200. That's going to get added to that first row. And then I'm going to slap the same thing on this bottom row, or this third row. You guys with me on that? That's just multiplying my pivot row by -4 and kind of writing it next to those so I can do some arithmetic here. Whoa, the glue does not come off. Not good. Perfect. If I erase the constraints and the objective, we won't have to figure out what it means at the end. Alright, so apparently we're doing everything in black from now on. So what's my top row become?
I don't have the top one.
0, 3, -8.
So 0, 3, -8.
1, -1, 0, 0, 600.
Let's see, do I still have the right number of things? 0, 3, -8, 1, -1, 0, 0, 600. Cool. And then what about my second row?
Leave it.
Leave it. So that's 1, 3/4,
2,
2,
0,
0.
1/4, 0, 0, 550.
Okay, perfect. And the third constraint row becomes 0, 0,
-4,
-4,
0, -1, 1, 0, 100.
Cool. And what do I want to do with this bottom row?
You just want to add row 2 to it, right?
Yeah, I really just want to add it. I'm not going to do that right now because I feel like I've done enough arithmetic to this thing to screw it up. So I'm just going to rewrite it. So I got -1, -1, -1, 0, 0, 0, 1, 0. Okay? All right, now off in the margin here, I need to write what? So I want to make this 0, right? So I need to add row 2 to row 3. Sorry, row 2 to row 4, thank you. So I'm just going to write row 2 underneath here to not screw myself up. Okay, and then I'm going to make another copy.
Will the top 3 stay the same?
Top 3 stay exactly the same. So 0, 3, -8, 1, -1, 0, 0, 600. 1, 3/4, 2, 0, 1/4, 0, 0, 550. And 0, 0, -4, 0, -1, 1, 0, 100. And on the bottom, now I'm going to have 0, thankfully. And what else?
-1/4,
-1/4,
1,
1,
0,
0,
1/4,
1/4,
0,
0, 1,
550.
550. Okay, so if I pulled the identity rows out of this, or the identity columns, what does that say? Where am I now?
Wait, how do you get
1 equals 550.
Say again.
How do you get the row 4?
This one or that one?
So that one.
So this is 1/4 plus that 0 is
Oh, okay.
1/4 total. Okay, so if I read off the identity rows, what this means is I'm making 550 box 1s, right? I have, what's that row?
That's the
Box 1, box
pivot
2,
slack.
box 3, slack 1. So that means I'm unusing, right? I'm not using 600 of the pippin apples. And I'm also not using
100 of the mac.
100 of the bougies. Okay, see that? So I've got some apples left over, right? And this thing says, hey, you're not done yet, right? So what I did was I used up all the, what did I even use up? I made as many box ones as I could. And now I've got some more making that I could do. So what do I do
What
now?
does that tell you right now?
What's that?
That 100, what does that tell you right now?
So this 100 and this column here, that's
Yeah.
identity column, is telling me that the Fuji apples, okay, this would be easier if I had the labels. This is box ones, box twos, box threes, slack ones, slack two, slack three, and C's. So this one here and this 100 there are telling me that the Fuji apples that I have left are 100. So I got 100 Fuji apples left and 600 Macintosh apples left, and I could probably do better than having 700 apples left on the ground, right? So what's this thing?
Greatest reward.
Yeah, that's my biggest payoff again, right? You guys see that?
Yeah.
So there's a payoff to be had. It's at making some more box twos. And so what do I need to do with the minus 1/4? Like what does that do? What do I need to think about?
Find the most constraining constraint in that column.
Okay, so that's identifying a payoff column, right? So here's my payoff column, that second one. And now I need to find the most constraining constraint there. So what are my quotients there?
You have 200 for the first one.
Okay, so I took 600, I divide by 3, right? That's this 600 divided by that 3, gives me 200 out of this one.
Not gonna worry about that one. It's bigger than
Yeah, it's like 733.
Okay, bigger,
2. And ignore zeros.
and ignore zeros.
So if that's 0, you just leave it as the 100 because you can't divide by 0? Or
There was a caveat in the description,
book
you
said
didn't
ignore
read.
zeros and negatives.
Yeah, so the book probably says to ignore zeros and negatives. I would say this. We're looking for the smallest payoff, right? We're looking for the smallest quotient, the most constraining constraint. This constraint equation, it doesn't use up any of these. So I don't really care. Another way to think about that would be to say, okay, how big is 100 split no way is going to be? That's going to be big, right? Because we got to get rid of 100 things. We're going to split it between nobody. Everybody's going to have to take home infinitely many things. You could use this definition if you wanted.
Nonsense.
This would work in there. Okay. You could just assume if you're going to divide by 0, you get positive infinity. Okay, so I got 200 bigger and infinity. So of those, the smallest one is
200.
200, I think. So here's my constraining constraint, which means that the pivot is
3.
this 3 in the
So
second column.
If like the 3/4, or instead of a 0, you had like a -2, would you also just kind of, it doesn't count, you just.
Yeah, I'd ignore that too.
So you wouldn't use it at all, or you just use a 2 instead of a -2?
I wouldn't use it at all. Because that means that, right, that negative means that if I make more of these with that constraint, I'm going to get extra leftovers, basically. So it's not going to cost me anything, right? It's not a constraining constraint because it doesn't care.
Okay.
So I need to make this my pivot. So what do I do?
Make it 1.
Make it 1. Okay. So I'm going to what?
Start doing some more pivot stuff.
Start doing more pivot stuff. Okay, so I'm going to leave the bottom 3 rows alone. So I'm just going to rewrite those. So I got 0, -1/4, 1, 0, 1/4, 0, 1, 550 in my bottom. I got 0, 0, -4, 0, -1, 1, 0, 100 in my second from the bottom. I got 1 3/4, 2 0, 1/4, 0 0 5/50 in my second row, and the top row becomes what? 0 1 -8/3. Oh goody. 1/3 minus 1/3. 0 0 and 200. Oh goody. And now we get to play fraction there. Okay, so now what do I want to do with this? Yep. Here we go. So I need to make this bit 0 and that bit 0, right?
Oh my god.
Okay, so I'm going to do this at the same time, and it's going to suck, but bear with me. So I need to multiply this whole thing by -3/4, right, to get rid of the 3/4 in the second row. So I'm going to get 0, -3/4,
I have a question.
and
2.
+2.
Hey, I have a question.
What?
Why do you have to make the 3/4 a 0?
Because I'm trying to make this an identity column so I can read off how many box 2s I'm going to make.
Okay.
So let's see. -8/3 times -3/4 is positive. The 3's cancel and some 4's cancel, so I get 2. It's okay if you have to do that off to the side. What's 1/3 times -3/4? -1/4. And this is going to be +1/4. And then I've got 0 and 0, thankfully. And 550 times -3/4 is
200 times
oh, crap, thank you. 200 times -3/4 is -150. Okay, good, thank you. All right, so that's what I need to add to the second row. What do I need to add to the bottom row?
Nothing, it's already 0. Oh, the bottom row, sorry. I'm looking at the third row.
Sorry, this one's good, yeah. My third constraint's good. My objective equation has this -1/4 in it, which I would like to get rid of. So I'm going to do that at the same time because I've been writing too much and I'm tired of it. So I need to multiply this thing by what to get that going?
+1/4?
+1/4. So I got 0/4 minus 2/3.
12.
What?
For the next one.
A 12 minus a 12, 0 0 and 50. Okay. So, top row. Yeah, don't do anything to the top row. So I got 0 1 minus 8/3, 1/3 minus 1/3, 0 0 200 there. Third row.
Nothing.
Nothing. So I'm going to have 0 0 -4 0 -1 1 0 100 in that. Middle row.
1 0 4.
1 0 4
Negative.
-1/4
1 half.
1/2 0 0 400. You guys follow with that? That's adding this black and blue together, right? Okay, last row needs to be this black and this blue added together. So I think I got 0 0 1/3. I like to see that.
1/12.
A 12.
A 6.
A 6. Quarters 3/12. Take away one of them, 2/12 reduces to a 6. Fraction arithmetic is fun. 0, 1, and 600. Whew. Okay, now
Oh,
what?
done.
Yeah, I'm done now. You guys realize why?
Because there's
no more
there's no bigger profit.
Yeah, there's no negatives in the bottom row. So now I'm done. And I can, using my identity columns, read off what the answer was.
You can make
Okay, so that's, so I need this column here, this column here, this column here, this column here, and that stuff. Right? So if I pull those out and write them down over here, I have 0, 1, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, and 0, 0, 0, 1. And my numbers are 200, 400, 100, and 600. And why have I been dishonest with you just now?
We have no variables like
Good. You need to remember where these things came from. So where did this first column come from?
box 1,
That was the box 1 things.
box 2,
That was box 2 things.
Slack
slash
3.
3.
Oh, slack
Why?
3.
Yeah, we
Weird.
don't use all the Fuji's.
Okay, and then
It's easy.
that was Z. Okay, so what I found out is, how many box 1s am I making?
400.
400. Right, that's right here. How many box 2s am I going to make? 200. And I would like this to read how many box 3s am I making, right?
None.
I have no idea.
Or if you have 600 total.
Yeah.
We assign all the ones that aren't the identity to be.
So let me talk about this first. So then I had Y3 out of here, right? What's that?
Fuji, yeah.
That's the Fuji apples. There's 100 of those. And then Z is 600. So I would like to answer the question of how many boxes of each type do I make, right? But I don't know that information right off the top of my head here, unless I do a little arithmetic at least. So, what was box 1?
4, 4, 4.
Okay, so maybe to write my sentence, I should start composing my sentence. You should make 400 box 1s. I'm not ever sure how to. How many box 2s?
200.
200. And how do you know there aren't any box 3s?
Out of supplies.
You don't have
Yeah,
enough
that's how we do it.
apples or mangoes.
Yeah, you're out of supplies. Another way to say that, right, is to see that the total number of boxes you're going to make is 600, right? If you make 400 box 1s and 200 box 2s, you already made them all, so there aren't any box 3s. And then what's the meaning of this Y3 is 100?
We have 100 Fuji left over.
Yeah.
Which is stupid because Fuji's the best.
Well, so people would want to buy them by themselves, so you could probably just sell Fiji by themselves.
Oh,
So
well,
the
I wrote
farms-
down this, which is close to sell them by themselves. Right, you have 100 leftover Fuji apples, so do whatever it makes sense to do with them.
Could you eat 100 Fuji apples?
Well,
Watch me.
100 workers could eat 100 Fuji
Yes.
apples.
So here's a question. How many other apples do I have left over?
None.
Probably.
Do I know right off the top of my head here? Like, what variables would I be looking for to represent those?
Y1 and Y2.
I mean, I don't know. There's numbers in the Y1 and Y2 columns in these constraints, right? They're all tangled into everything. We could make equations out of this and figure it out. Or we could think about how many Pippin apples am I going to use making 400 box ones?
1600.
Like,
Yeah.
this is going to make 1,600 Pippin apples get used up, right?
And then
1,600
plus a 12.
Max and 1,600 Fujis, right?
Yeah.
And then making 200 box twos is going to use how much? 1,200 Pippins. Okay, so I did use all the Pippins.
600 max.
600 Max, so it sounds like I also used all the Max. And then also 600 Fuji, right?
Yes.
Yeah, you don't have any left over.
So I don't have any Pippins or Max left over. But I don't know that until I go back and think about it. You guys see that? Like, this thing right as it is, oh, I erased the one I was using. This thing right here, right as it was, doesn't tell you anything a priori about Y1 and Y2.
Does the
Or
path
box
you
3.
follow through your matrix tell you anything? Because like you use those two constraint rows or columns. So would that tell you that?
So the first movement definitely said I was gonna, hey, you're gonna use up all of the available, like you're gonna box as many boxes as you can out of the Pippin apples, or whatever the most constraining constraint on the first one was. But,
That might be reversed by switching constraints.
well, my constraints had nice even numbers on the number sides, right? They didn't really have to. They could have, I would have gotten similar results if they had been, instead of 2,800, if they had been 2,801, and 2,201, and 2,301, right? I know these and ones aren't going to get used up because all my boxes contain even numbers of apples.
Can you do it with like D3 being the first?
Yeah, of course, we could have made that first movement in any direction. I think we still would have ended up at 600 boxes.
Yeah, and then you wouldn't know.
It's also not it's not entirely clear that it would be the same 600 boxes, but I think it probably would.
Okay.
There is a way to make a problem that would have multiple 600 box solutions. I don't know if this is one of them.
Regardless, we'd end up with one of those vertices.
Yeah, regardless, you'll end up with 600 boxes. They might not be the same 600 boxes, but you will end up at 600 boxes.
So then what if you assigned a different price to each box? You know, box 1 sells for 2, box 2 sells for 3.
Yeah, then
and
you're...
then would you want to like go different paths to try and find out which 600 boxes gets you the most profit? Or is there an easier way to do that?
So, you wouldn't want to be maximizing the total number of boxes,
You want to
right? Your
maximize
objective
that.
equation would be different, and so from the beginning, your payoffs would be different.
Okay.
Right, here we had even payoffs because a box is a box is a box, right? But if they were different amounts of money that I was making out of them, then I would shoot for making as many high-priced boxes as I could right off the bat.
Okay.
You guys see that?